follow along to do some practice problems on special limits. There's only a few that in my opinion, are actually special limits, the special trig limits specifically. Otherwise, they're pretty not special in my opinion. They're pretty typical. Okay, number one, find this limit. So go ahead and try this one on your own. You might have learned this in class even before calculus, when you start learning about end behavior functions. Okay, I think they changed up the curriculum because I remember back when I was in algebra 2 and all that, I don't recall learning about end behavior. I'd learned about asymptotes, but they never said the term end behavior. But this topic is now more common, at least for the students that I tutor, in um, yeah, more common in classes before calculus actually, and this is actually in AP pre-calculus as well. But anyway, this is asking about the end behavior, the end behavior of this function. So what happens when x keeps growing? You can just imagine that if we plug in x is like 10 or 1 billion, I guess is what I wrote, 1 billion. So a billion squared minus a billion plus 18. A billion squared is so much bigger than a billion. Okay, and it's obviously so much bigger than 18. You can see how as x keeps getting bigger, this 4x squared term is the only thing that's really significant. Okay, so what happens as x keeps growing? This will blow up to infinity, and that's our answer. The limit's infinity. Okay, and we have to pay attention to the sign as well. Is it positive infinity or negative infinity? It's positive infinity in this case. Okay. Yeah, as I said, this one I don't think is really that special. It's pretty simple, actually. Now this one, how do we solve this one? This is a special trig limit, I'll say right away. Okay, so we can use L'Hopital's rule if you know it. And it's actually quite easy with L'Hopital's rule, but let's assume we don't know it. Okay, this is how we solve it. We want to make this guy look like the special trig limit cosine x minus 1 over x as x approaches 0. This is equal to 0. Okay, that's the special trig limit you have to remember. So the other one is sine x over x. That one as limit as x approaches 0 for that is 1. Okay, so we want to make this guy look like this. How do we do that? Well, we can factor out a -1 first. So cosine of 7x minus 1 over 7. So it looks a little closer, right? The only difference is I have 7x inside the cosine, the argument of the cosine. And that's the only difference, yeah. Except it's minus sign as well, but that's just multiplying it, okay? But the inside of the limit, that's the only difference. So let's make a substitution, okay? Let's let u be 7x. Okay, we're going to define a new variable u as 7x. So if you're here to review for the exam and you learn about u sub and integrals and all that, this should be not new at all. But if you're here learning this you didn't learn about integrals and all that yet, let's understand that we're just changing the variable. We're defining a new variable u, and we're saying that u is 7x, okay? So what happens when x approaches 0? What would u approach? Okay, so as x approaches 0, 7x will also approach 0. Okay, so imagine this is the equal sign. It's not really, but just imagine, okay? Multiply by 7 on both sides. So 7x will still approach 0, which makes sense as x approaches 0. 7 times something that's approaching 0 would be approaching 0 as well, okay? In other words, since 7x approaches 0 and we're saying u equals 7x, we can say u is approaching 0, okay? So let's rewrite the limit now in terms of u, okay? So limit as u approaches 0 of cosine u minus 1 over u over 7. So let me go over this again a little slower. So 7x is u. That's what happened there. X, we can get from dividing by 7 on both sides. U over 7. So we need this variable x to be u. So that's why I was saying over here, u approaches 0. Okay? So that's what happened there. This minus sign stays the same. Okay. Doesn't this look a lot closer to this now, except one's x, one's u? U over 7, that's the same thing as multiplying by 7 and then divided by u, or multiplying by 7 over u, essentially. So we can pull that 7 out. Okay, now this looks exactly like this, except one variable is x, one variable is u. Doesn't matter the variable name, this limit is still 0. So minus 7 times 0 equals 0. That's how we solve this one using the special trig limit. The whole idea is you want to make this guy look like the one you memorized. Okay, hopefully the substitution made sense. Okay, with L'Hopital's rule, you can see how easy this is. It's 0 over 0. So we differentiate the top, that's just 7 sine 7x. Differentiate the bottom, that's just 1. Plug in, that's 0. Easy. How about number 3? How do we solve this limit? And we're going to use the same technique as the other one. We want to make it look like our special trig limit we memorized, okay? So we let u be x squared, for example, okay? As x approaches 0, hopefully you would agree that x squared would also approach 0. Okay, you can imagine I just squared both sides, okay? Which means since u is x squared, u approaches 0. Okay, so let's rewrite this limit in terms of u. Okay, so it would be cosine of u, because x squared is u, and this we rewrite as u as well. Okay, so what do you do from here? Well, we can divide by 3. We can simplify the 3 and the 9. Okay, yeah, divide by 9 essentially to both these terms. So you just get 3 on the bottom. Okay, now this 3 on the bottom is essentially a 1/3 being multiplied to cosine u minus 1 over u. So move that 1/3 out in front of the limit. It's constant. Okay, this is exactly our special trig limit, except one is using the variable u instead, but that doesn't matter. The value is still 0. So 1/3 times 0 is 0. So this limit is 0 as well. Okay, with L'Hopital's rule, we just use the chain rule on the top and then power rule on the bottom. Okay, and then you do the limit, it's 0 as well. Okay, last limit. Limit as x approaches infinity, 4x to negative 2 over x to the 3rd power. Hopefully this was simple enough that this is not a special one. In my opinion, it's pretty straightforward. We just move the x to minus 2 into the bottom of the fraction as a positive exponent. So it's 4x to the 5th. We take the limit as x approaches 0. The bottom will blow up, which means we're approaching 0. Okay. That's it for this video. Hopefully it was simple enough. The point is, the main takeaway, hopefully, is how to use the special trig limits. The ones that look like it. If not, if you don't know L'Hopital's rule. L'Hopital's rule, you can see it's much easier. But if you don't know it, then you have to do something like this. All right? Hopefully see you in another video as well. Bye.